All right, guys, we're going to add some new stuff to our notebook today. Actually, it's not super new. We're still going to be multiplying, but we're going to look at some special cases. So special products, and we're going to do that on page 96. Okay, and we actually already saw this if we did all the examples in our multiplying madness. So actually, if I do a little preview there, a couple of the last few ones that I did in the second video were like this. The first one I actually want to talk about is when we were doing some of the area stuff. So when I did like the area of this square, I was doing the same thing times itself. And then I did that again with the circle. So that's actually the first thing that I want to look at. So on page 96 at the top here, we're going to talk about these three special products. So as a little bit of a preview, if I had like x plus 2 squared or x plus 7 squared or 2x plus 1 squared, the things that all of these have in common is that we are squaring a sum. Now, when I actually do it, the way that I should think about this is I should really write it twice and then FOIL or do the box or distribute twice or whatever. But something super interesting happens when you do, and it's kind of a shortcut. So if I do this quickly, this guy turns into x squared plus 4x plus 4. The next one turns into x squared plus 14x plus 49. And like I'm doing it quickly, like combining like terms in my head because I already know the trick. Or this last one is like 4x squared plus 4x plus 1. So this first one, if we take a look down here, square of a sum, what happens every time when I have two numbers that are being added and squared, I need to write it twice. And when I actually end up doing that, a times a is a squared. And then when I do the outer terms, we get an AB. And when I do the inner terms, I also get an AB. And then when I do the last two, we get a B squared. So when I combine like terms, I always end up with a squared plus 2ABs plus B squared. Now this is a shortcut, and the way that I really think about it is I square the first number, 2 times the first number and the second number, and then I square the last, or the second number. Okay, so I know maybe that doesn't seem like a shortcut, but it's kind of not so bad. If I'm looking at this new one here, I square the first number, I double the first and second numbers. So if I smash these two together, that's 5x, and then if I double it, it's 10. And then I square the last number, and 5 squared is 25. So then we can do it fast. Okay, on to the next. If I square that first one, it's 4x squared. If I smash these together, that's 6. And then if I double it, it's 12. And then I square the last for 9. Okay, so hopefully that kind of makes sense. Now, one that's very similar to that is instead of adding, maybe I just subtract. So like x minus 2 squared or x minus 7 squared, or 2x minus 1 squared. So squaring a difference, or like a subtraction. So same idea, I would need to write it twice. and then I would do like FOIL or the box or whatever. But the more and more we do this same number of times itself sort of deal, hopefully we notice a pattern. So when we do it quickly, we get x squared minus 4x plus 4, x squared minus 14x plus 49, or 4x squared minus 4x plus 1. So like if you take a look, these answers are really the same numbers. The only difference is that first sign is subtraction now, which kind of makes sense. So if we look at this next one here, the square of a difference. Again, if I have two numbers being subtracted and squared, we want to think about writing that twice and then like distributing twice. So a times a is a squared. Then I get negative ab, and then another negative ab. Ooh. So that's why I have two of them. And then lastly, a negative times a negative is a positive. So like that's where the negative comes from, but then the last number is still positive because of negative times a negative, and then b squared. So again, like when I combine my like terms, we'll have two negative ab's. So again, the real difference here is just that it's subtraction on that middle number rather than addition. And again, the way that I'm thinking about it quickly is I square the first. 2 times the first times the second, and it's always going to be negative, and then I square the second. So square the first, 2 times the first times the second, but always subtraction. So when I smash those together, it's 5x, doubled is 10x, and then square the last for 25. So you can do it slow, but it's kind of nice to know a trick. So same thing for all of these. I square the first, I smash the two together and double it, so negative 16x, and then I square the second, so 64. I square the first, I smash these two together and then double it, so negative 6x, and then I square the last. Square the first, smash those two together, so negative 6, but then double it, so negative 12, and then square the last. I square the first, smash those two together, so negative 5, and then double it for negative 10, and then square the last, and 1 squared is 1. Oh my gosh, I almost put 2. And then lastly, oh my word, I square the first, which is going to be 9x to the 4th. Because if I square it, I got to multiply. I smash these two together for negative 21, and then I double it for negative 42x squared, and then I square the last for 49. Last but not least, these are kind of the two trickier ones. I like this last one the best. If I multiply one that's adding and one that's subtracting, so like x minus 2, x plus 2, or x plus 7, x minus 7, or 2x plus 1, 2x minus 1, what's going to happen every time when I do it slow is those middle two terms, one will be positive and one will be negative, right? So like we'll have 2x, negative 2x, that's 0. Negative 7x, positive 7x, that's 0. Your middle two terms will always be opposites, so they always end up going away. My thing came unstapled. It's real tragic. So when I do a times a, that's a squared. Oh my word. Outer, I get negative ab. Inner, I get positive ab. And then last, a positive times a negative is a negative b squared. Now, again, because these are opposites in the same number, that's just 0. So I'm left with a squared minus b squared. So this one is so nice because I just square the first, square the first minus the square of the second. And that's it. These ones are so nice. But it has to follow that pattern. Like you have to have the same exact numbers, except for one's a plus and one's a minus. So I square the first minus square the second. And the number is the same in both, so it kind of doesn't matter. So because I have the same two numbers, but one's a plus, one's a minus, I can square the first minus the square of the second. Because I have the same numbers, one's a plus, one's a minus, I square the first minus the square of the second. Because I have the same numbers, oh my gosh, that's the same as this one. I can square the first minus the square of the second. Same numbers, one's a minus, one's a plus, I square the first one minus I square the second one. Even when it gets trickier, same two numbers, one's a plus, one's a minus, I square the first one and then I square the second one, always a minus. Same deal here, same two numbers in both, one's a plus, one's a minus, I square the first and then I square the second, always a minus. Same numbers and same letters, one's a plus, one's a minus, so I square the first, I square the second, always a minus. And lastly, same numbers, same letters, same powers, one's a plus, one's a minus, I square the first, so like 3 times 3 is 9, x squared times x squared is x to the 4th, oh my gosh, I said it, but I didn't write it. And then I square the second, 2 squared is 4, y squared is y squared, always a minus. And there you go.